Today we'll be looking at a few standard integrals that you might come across when you're solving integration problems. And there's quite a few of them, so we'll try to go through as many as we can. So the first one that you might have seen before is the integral of a constant k. So the formula tells us that when we are trying to integrate a constant k, we just multiply that by the answer is just the constant multiplied by the variable x plus c. So in our case here, we are integrating in terms of x. So x is our variable. So the integral of k dx is just equal to kx plus c. And of course, c here is the constant of integration. So if we look at a few examples, when we're trying to find the integral of the constant 4, based on what the first rule tells us is that when you're trying to find that integral, this is just equal to 4x plus c, right? Same applies for the integral of -1 over 7, which will just be -1 over 7x plus a constant of integration c. Once again, it's the same for -5. The integral of -5 will just be -5x plus c, right? So this is a pretty straightforward rule. You must have seen it before, so it's quite simple, right? So now moving on to the second one, which is looking at the integral of a variable x to some exponent n, right? So the rule tells us that when you have a case like that, what you do is that integral is just equal to x to the n plus 1, right, divided by n plus 1 plus c. Once again, c is the constant of integration, and n is just a constant, any constant, right? So if you look at the examples, the first example here, we have the integral of x to the 7. So based on what that rule tells us, we will have x to the 8, right? 7 plus 8. Sorry, 7 plus 1, so that's 8. X to the 8 divided by 8 plus the constant of integration c, right? The same applies to the next one, but now we'll try to simplify the next one before we do the integration so it's a little bit more clear. We know that the square root of x to the 5 is just x to the 5 over 2. And that integral, based on what the rule tells us, is just equal to x to the 5 over 2 plus 1, which is 7 over 2, divided by 7 over 2, plus c, the constant of integration. And this can be further simplified to just be 2 over 7, right, multiplied by the square roots of x to the 7 plus c, right? The next one, we have the integral of 1 over the square root of x to the 3, or x cubed. That will just also be simplified as to be x to the -3 over 2, right? So that is the same thing. And that integral, based on what the standard integral tells us, is x to the -3 over 2 plus 1, which is x to the -1 over 2, divided by -1 over 2 plus c, the constant of integration. And this can be further simplified to just be -2 divided by the square root of x plus the constant of integration c. right? So you can clearly see that there's a pattern to these types of integrals. So now, if we look at the next few types of standard integrals, we have the integral of 1 over x, which we know is just equal to ln of x, or in this case, the absolute value of x plus c. And because remember, x can be positive or negative, but we can never have the ln of a negative number, so we have to take the absolute value to both include positive and negative values of x, such that the absolute value would be a positive number always. So, and the next one is just the standard integral of e to the x, which is just e to the x plus c, the constant of integration. And the fifth one is the integral of b, some constant b, to the variable x, to the exponent of the variable x dx. And that rule tells us that that integral is just equal to b to the x divided by ln of b plus the constant of integration. So if we apply it to these examples, the integral of 5 to the x will just be then 5 to the x, right, divided by ln of 5 plus the constant. Same applies for the next one, which is the integral of 9 to the x, which will just be 9 to the x divided by ln of 9 plus the constant of integration c. And the next one is the integral of 1 to the 4, right, which once again will just be equal to 1 over 4 to the x divided by ln of 1 over 4 plus the constant of integration c. And now if you look at the next few types of standard integrals, we have the standard integral of sine x, which we know is just equal to negative cos x plus the constant of integration. And the integral of cos x is just sine x plus our constant of integration. The integral of sec squared x is just equal to it's just equal to tan x plus the constant of integration. And the integral of cosec squared of x is just equal to negative cot x plus c, the constant. And when we have the integral of sec of x multiplied by tan of x, we remember that that is just equal to sec of x plus our constant c. And looking at the integral of cosec of x multiplied by cot of x, then we have similarly negative cosec of x plus our constant c. And our integral of tan of x is equal to negative ln of the absolute value of cos x plus c. Once again, the reason why we have included the absolute value here is because cos of x can have negative values, so, and we can never have the ln of a negative number. So by including the absolute value, we eliminate the chance of ever having a negative under the ln. And so the integral of cot of x is also similarly equal to just ln of the absolute value of sine x plus our constant of integration c. The next one is the integral of dx over the square root of a squared minus x squared. Now a is a constant, any constant, and x is our variable that we're integrating in terms of. So all generic integrals of that form are just equal to the inverse sine of x over a, that's the general formula, plus a constant c. Right. So that's for all integrals of this form. And to illustrate that, we have just a few examples here, where we have the integral of dx over the square root of 25 minus x squared. We note that 25 is just 5 squared, right? So in our case, a is equal to 5, right? So therefore, this integral is just equal to, let's copy that, bring it over there. It's just equal to x over 5, the sine inverse of x over 5 plus c, right? That's straightforward. And in our next case, we have the integral of dx over the square root of 1 over 9 minus x squared. Once again, we note that 1 over 9 is just equal to 1 over 3 squared. Right, so if we were to rewrite this as 1 over 3 in brackets squared, then we note that our a for our formula will just be then 1 over 3. So we have x over 1 over 3 sine inverse of x over 1 over 3 plus c, which can further be simplified to just be sine inverse of 3x plus c. Right. And looking at the next one, we have the standard form of the integral of dx over a squared plus x squared. And this is all integrals of this general form are also equal to just 1 over a multiplied by tan inverse of x over a plus c, our constant of integration. And if we apply that to our example here, we have the integral of dx over 16 plus x squared. And 16 we know is just 4 squared, right? So based on our formula, our a here is just equal to 4, right? So if we apply the formula, we'll just see that that is just equal, that integral is just equal to 1 over 4 multiplied by tan inverse of x over 4 plus a constant of integration c, right? And the next example is the integral of dx over 1 over 25 plus x squared. Once again, we know that 1 over 25 is just 1 over 5 squared. And in that case, then our a is 1 over 5. So we have that integral being equal to 1 over 5, right? multiplied by tan inverse of x over 1 over 5 plus c. And 1 over 1 over 5 is just 5. And that is multiplied by tan inverse of 5x. Right. If we simplify, and plus c, the constant. So as you can see, if you understand the sort of pattern, you can quickly evaluate these integrals, which is why these standard integrals are particularly helpful in cases like the ones we'll be looking at in this part of the module. So if we look at the next standard form, which is the integral of dx over x multiplied by the square root of x squared minus a squared, that general form, for that general form, we have that is just equal to 1 over a multiplied by sec inverse of the absolute value of x over a plus c. Well, right, and so in this case we have that a has to be a positive a is a positive value, right? So that's that for these types of examples. And if we were to apply this to a specific example, you have the integral of dx over the square over x multiplied by the square root of x squared minus 81. In that case, we can see that if we were to introduce, we can see that 81 is just 9 squared. It's just 9 squared. So this can just be rewritten to be the integral of dx over x multiplied by the square root of x squared minus 9 squared. And in that case, our a is just 9. So we have that equal to 1 over 9 multiplied by the sec inverse of x over 9 plus c. The next general form that we'll be looking at is the integral of dx over the square root of a squared plus x squared. Now this particular general form has as a solution ln of x plus the square root of a squared plus x squared plus our constant of integration c. And if we were to apply this to this our particular example here, we can see that we have the derivative, is rather the integral of dx over the square root of 5 plus x squared. And we know that 5 is just the same as the square root of 5 squared. Right? This can be rewritten as such. And when you do that, you quickly note that our a then for this specific example is just equal to the square root of of 5. So we have here the square root of 5 squared. So we have the entire solution to be ln of x plus the square root of 5 squared plus x squared, all plus c, the constant of integration. Right, so the next example is asking us to find the integral of dx over the square root of 36 plus x squared. Now we can quickly see that 36 is just 6 squared. So a, once again, here is just 6. Applying the formula, we get that integral is just equal to ln of x plus the square root of 6 squared, right, plus x squared, all plus the constant of integration c. The next general form that we'll be looking at is when we have the integral of dx over the square root of x squared minus a squared, which is different from when we had the case of the integral of dx over the square root of a squared minus x squared. So those two are different cases. For the integral of dx over the square root of x squared minus a squared, that integral has the general form as a solution of ln of the absolute value of x plus the square root of x squared minus a squared plus a constant c. Once again, here we are doing this for positive values of a sorry. So we could say that a is greater than 0. And if we apply this to our example, we have the integral of dx over the square root of x squared minus 49. And we quickly note that 49 is just 7 squared. So we have the integral of dx over the square root of x squared minus 7 squared. And if we look at our formula, we see that our a is just 7. So we have ln of the absolute value of x plus the square root of x squared minus 7 squared, all plus the constant of integration c. Now, the next form is looking at the integral of dx over a squared minus x squared, which should not be confused with the integral of a squared of dx over a squared plus x squared. So those are two different integrals as well. So we should pay attention to that. So integrals of this general form have the solution of the form 1 over 2a, right? Once again, a is our constant, multiplied by ln of the absolute value of a plus x divided by a minus x plus our constant c. Now, if we look at this example, the integral of dx over 36 minus x squared is just similar to the integral of dx over 6 squared, which is just 36, minus a squared. So for this specific example, our a is equal to 6. And therefore, this integral is just equal to 1 over 2 times 6, which is 12, multiplied by ln of 6 plus a divided by 6 minus a. That's all under the absolute value sign, plus our constant of integration c. The next general form that we look at is the integral of dx over x multiplied by the square root of a minus x squared, which again should not be confused with the integral of dx over x multiplied by x squared minus a squared. So those are two different integrals with two different solutions. So for these types of integrals, we have that is just equal to the general form of 1 over a multiplied by ln with the absolute value of a plus the square root of a squared minus x squared divided by x plus our constant of integration c. Now, if we were to apply this to an example, we have the integral of dx over x multiplied by the square root of 7 minus x squared. Now, we can see that 7 is just the square root of 7 squared, right? So we can rewrite it as the integral of dx divided by x multiplied by the square root of the square root of 7 squared minus x squared. And when we apply that to our formula, general formula here, we have that it's equal to negative 1 over the square root of 7 multiplied by ln of the square root of 7 plus the square root of 7, the square root of the square root of the square root of 7 squared, which is just 7, minus 8x squared, all divided by x under the absolute value sign, plus our constant of integration c. So I know this might seem a bit overwhelming at this point, but we'll look at a few exercises when we're done to get you a little bit more comfortable when dealing with these types of questions. So the last standard integral that we'll look at is the integrals of the form dx over x multiplied by the square root of a squared plus x squared. And those integrals of that type have the general form of negative 1 over a multiplied by ln of the absolute value of a plus the square root of the square root of a squared plus x squared all divided by x plus our constant of integration c. So that's the general form. And for a specific example, we look at the integral of dx over x multiplied by the square root of 3 plus x squared. And now obviously 3 is just the square root of 3 squared. So in our case, a is just equal to the square root of 3. So knowing that, if we apply this to our formula, we find that it's just equal to negative 1 over the square root of 3 multiplied by ln of the square root of 3 plus the square root of the square root of 3 squared, which is just 3 plus x squared, all divided by the square root of x under the absolute value sign plus the constant of integration c. So that's the last standard integral that we'll be looking at. And I know it's quite a few, but with the exercises that we'll look at in the next video, it should make this a little bit more clear for you to get comfortable solving these types of problems. Right, so see you in the next video. Thank you for watching.